Okay, we are starting Unit 4, which is Properties of Triangles. We're going to be working on pages 3 and 4 in this video. It should mostly be review from things you've done in middle school. We're just going to make sure that it's really solid before moving on. So we're starting on page 3. We're skipping this first activity, but please get out your red pen so we can fill in this box. So the sum of interior angle measures of a triangle. Most of you already know this, but the interior angles of a triangle just always add up to 180 degrees. Okay, so if I have some triangle, A, B, and C, the measure of angle A plus the measure of angle B plus the measure of angle C will always add up to 180 degrees. And this fact is going to be the basis of a lot of things we do throughout the year. And then when you're naming a triangle, pretty simple notation, you use a little triangle symbol and then you just list the vertices using capital letters. So this could have been triangle ABC. The order doesn't actually matter for now. It could be ABC, it could be BCA, it could be ACB, lots of different options. So for now, the order doesn't matter. Okay, so now we're just going to do some examples of finding missing angle measures. So we know that they add to 180. So you can either just kind of do it in your calculator, or you can always set up an equation. So if I'm looking for the measure of angle C right here, I know that that angle plus the other two angles have to sum to 180. So x plus 80 plus 55 is equal to 180. And then collect like terms, x plus 135 is equal to 180. And then x is equal to 45 degrees. So that means the measure of angle C is 45 degrees. Okay, now we're going to move over to example B. So here I have something a little bit different where I have these tick marks. Okay, so I have it marked that angle A is congruent to angle C. Okay, so I can do this a couple different ways. I could kind of just think about it. So I know that angle B is 100 degrees, which means I have 80 degrees left over, and I need to split that into two congruent pieces, so that would need to be 40. The other thing I can do is I can just set up an equation. Since I know they're the same, I'm going to call them both x. So angle A, which is x, plus angle C, which is x, plus angle B, which is 100, needs to add to 180. Collect like terms. Subtract 100 from both sides, divide both sides by 2, and that's where I get angle C, A is 40 degrees, and angle C is 40 degrees. Some of you might recognize this type of triangle. That is an isosceles triangle, which we're going to define in a little bit. Isosceles, that's hard to spell. Okay, so we're going to kind of formally define that in a little bit, but hopefully some of you at least recognize that. Okay. So now we're doing the same thing, but instead of just solving for a missing angle, we're going to throw a little bit of algebra in there, but it's still exactly the same thing. Okay, so we know that our angles need to add to 180 degrees, and this angle now is just the quantity 3e, and we want to solve for e. So each angle, 3e is one angle, plus 60 is another angle, plus this is a 90-degree angle. Add to 180. Collect like terms. Subtract 150. And we get that E is equal to 10. Okay, and I can always plug that in and make sure it makes sense. Right, so that would be 3 times 10 here, so that's 30. And then 30 plus 60 plus 90 does give me 180. Okay, why don't you pause and try example B. Okay, and now check your answer. Make sure you set it up the same way. Okay, so what I did here was I had one angle, 2r plus 1, plus another angle, that's supposed to be this angle up here, is 110, plus the third angle is 35. Those need to add up to 180 degrees. And then I collected like terms, subtracted 146 from both sides, and divided by 2 to end up with r is equal to 17. Okay, now we're going to move to page 4. We're going to get your red pen back out. Oops. Okay, and really these are words that you probably already know, but we're just going to reiterate it and make sure that we really all know these. Okay, so we are going to be classifying by sides and by angles. Classifying by sides, we have three types. We have scalene, we have isosceles, and we have equilateral. Right? In a scalene triangle, none of the sides are the same measure. So an example would be just kind of like whatever, like just your normal triangle is going to be scalene. So this side could be 3, this side could be 5, and this side over here could be 7. Right? As long as they're all different, it is a scalene triangle. If you just have a triangle drawn and no tick marks or anything, you would assume it to be scalene because you're not told that anything is congruent. So if you should have a plain triangle, you would assume it to be scalene until you have more information. Isosceles triangles, a little bit more interesting. Isosceles triangles have at least 2 congruent sides. Okay, so that looks something like this, where at least 2 of the sides are congruent. Okay, it can be any orientation as long as they're marked. Okay, and then finally, equilateral. Hopefully we all know this one. All 3 sides are congruent. Okay, and that looks like this. Okay, so an equilateral triangle is a type of isosceles triangle because notice we said at least 2 congruent sides, so 3 congruent sides still is an isosceles triangle. It's just a special type of isosceles triangle. Okay, and we do have some vocabulary that goes with isosceles specifically. I'm just going to draw a bigger triangle down here so we can talk about it for a second. Okay, so it's an isosceles triangle because you have 2 congruent sides. Those congruent sides are called legs. The legs of the isosceles triangle are the congruent sides. And then, so let's do leg, leg. And then the non-congruent side, if it's not equilateral, if it's equilateral, these kind of go out the window. But if it is not equilateral, but it is isosceles, the non-congruent side is called the base. It doesn't necessarily mean the bottom, as I drew here, right? It just means the one that's not congruent. And then with that, we also have some information about angles in isosceles triangles. So in an isosceles triangle, if you kind of extend this tick mark and pretend like it's pointing at the angles, those angles also end up being congruent. And we're going to learn why later in this chapter. But the congruent angles are called the base angles, because notice that they're along the base, right? And then the non-congruent angle, the angle formed by the legs, is called the vertex angle. Okay, that's the non-congruent one. Okay, so this is the vertex. Okay, so this vocab is going to come up a lot. So I think probably the most important ones are knowing congruent sides are called legs, the non-congruent side is called the base, and then let's add a note that this does not have to be the bottom. I know base usually means bottom, but it does not have to mean that here. It does not have to be bottom side. My handwriting got a little bad there. Okay. And then classifying by angles, it's the same way as we classify just normal angles. Our 3 types are acute, right, and obtuse. Okay, so an acute triangle means that all 3 angles are acute. Right? Remember, acute means less than 90 degrees. In a right triangle, there's 1 right angle and 2 acute angles. right? We couldn't have more than one right angle because right angles are 90 degrees, right? And if we had another 90-degree angle on there, those two angles together would add to 180, right? So we wouldn't have room for a third angle. Okay, so if you have one right angle, you can only have two acute. And similar reasoning for obtuse. It's an obtuse triangle if there is one obtuse angle. The other two must be acute so that you can stay under 180. Okay, so acute kind of looks like this. Right, you would have a little mark there or be told that it's 90 degrees. Then obtuse has that one kind of wide angle and then two acute angles. We do have one additional term that is technically classifying by angles, and that is if something's equilateral, it is actually also equiangular. Okay, so the word, like the root lateral means side, and then angular kind of obviously means angle, but one implies the other. If something's equilateral, then all its angles are also the same. So we don't usually say equiangular, but it is technically a way to describe a triangle. But usually we just say equilateral because it implies equiangular. And then if we think about that, if all three of those angles are the same and they have to add to 180, they're each going to be 60 degrees, right? All three are the same. Okay. 3x is equal to 180. Each of those angles is 60 degrees. Okay, so that's a lot of information, but it should mostly be review. The main thing you might need to focus on is isosceles. So let's go down here and do a couple of practice problems. So why don't you pause this video now and then try A, B, and C, and we'll check your answers in a second. Okay, so looking at A, I would first look at the sides. None of those are the same. Okay, so that's going to be scalene. I could technically mark them if I wanted to, right? They're just all different, so I'd give them all tick marks. And then looking at the angles, acute, acute, and acute, you do need to check all three. Okay, so this would be scalene by sides and acute by angles. Moving over to B, looking at the sides, I have two of them marked congruent. Those two marked congruent, along with their congruent angles here, makes this isosceles. And then more specifically, we do have a 90-degree angle there. So this is a right isosceles triangle. And if you think about it, that would mean that both of these need to be the same measure. So if that's 90, we have 90 left over. Each of these is 45 degrees. Right? The question didn't ask you that. I'm just kind of talking through that. So let's just kind of practice the isosceles vocab here really quickly. So in this case, this would be my vertex. Right? It's formed by the legs. The legs are the congruent sides. The base is the non-congruent side. And then these angles that are one of the sides of each is the base are called the base angles. Okay, so again, that was just extra information, not what the question asked, but good to practice. And finally, over here, so we actually are missing a piece of information. We need to know what this angle is in order to actually classify this. So I'm just going to call it x. I'm going to do x plus 30 plus 50 is equal to 180. And again, if you have a faster way to do this and you don't need to write that out, that is totally fine. But we end up with x is equal to 100 degrees. Okay, so by angles, we do have an obtuse angle in there, which makes this an obtuse triangle. And then if you notice, when something's isosceles, it has two congruent angles. When something's equilateral, it has three congruent angles. And if you look up at A, this one was scalene. All of the angles were different as well. Okay, so we're going to make that connection later in this unit. But if all of the angles are different, all of the sides end up also being different. So this would have to be scalene. Okay, so you can kind of do that by elimination. So this is definitely not equilateral. It's not isosceles because there's no two congruent angles, so it would have to be scalene. Okay, down here, last couple. We're going to sketch and label these. So why don't you pause again, try filling this out. Right, and see if your sketches look something like mine. They don't have to look exactly the same, but it has to kind of meet the same criteria. So acute scalene, I needed to show that I knew all three angles were acute, so I just made up some angle measures that work. Right, they add to 180 and they're all acute. And then scalene, all of my sides needed to be different, so I used tick marks to show that. You could have shown it with with measures. It doesn't matter as long as you somehow showed that all of those are different. Obtuse isosceles, I have my legs marked congruent, and I have an obtuse angle. The obtuse angle has to be the vertex because I can't have two obtuse angles in a triangle or they're going to add to more than 180. Right, similar for the right isosceles, I needed a right angle in there, which also is going to be the vertex angle. And then I have my legs marked congruent as well as my base angles. And over here I have equilateral. The lateral means all of the sides are the same. Okay, but that also does imply that all of the angles are also the same. So all of those angles are actually also 60 degrees. Okay, make sure if you're in my class, you scan and submit pages 3 and 4 on Schoology.